Welcome to part 2 of the Masterclass. In this video, I'll briefly recap on part 1. I will go through neuroplasticity, I will cover exercises more specifically, and the balance or the vestibular system of the balance in more detail, and then how this applies to daily life and how it can affect daily life. So this is going to be good. Let's jump straight into it. Firstly, just to recap, the cerebellum is the area that we are developing. Small part at the back of the brain, about the size of a nachi or a satsuma, and it should be doing 50% of the work together with the cerebrum, the clever part at the front of the brain. They should be working 50-50. But in 20% of the population, 1 in every 5 people, that part of the brain is not doing its job. The cerebellum is not doing its job, which then leaves the cerebrum or the clever part at the front of the brain to do everything, which overloads this area of the brain. The fantastic thing is that once you have managed to stimulate and develop the cerebellum, you have literally another 50% of your brain to access. The overload on the cerebrum makes life very difficult at the time, because you're trying to process and do all of the tasks with that part of the brain. With the cerebellum not doing its regular tasks, the cerebrum is having to do everything. This makes the cerebrum work exceptionally hard, but the great thing about it is that it's used to working really hard. So once you manage to access the cerebellum and develop that, you literally have this extra 50% of the brain to use in the cerebellum, plus you have a cerebrum that's used to working really hard, so it's really well developed. And once you have working memory space in that part of the brain, everything starts to flow with a lot more ease. And that part of the brain, being well developed, is going to work optimally, and you have the cerebellum as well. So the whole processing ability of the brain is improved a huge amount. Neuroplasticity, remember, is the term that is used to describe the ability of the brain to change. So as the stimulation starts to develop the cerebellum, it will start to change. It'll start to build the neural pathways. They're like hundreds of little information highways that this information can flow along, which improves your processing ability. And that then frees up working memory space in the cerebrum for the real difficult tasks, the higher thought processes, working through emotional issues, so that you're able to work through things without flying off the handle, while the cerebellum does the more automatic tasks that you don't have to think about. So with the cerebrum having this extra working memory space, it's able to manipulate the information in the brain. So that ensures that it can work more efficiently. You can comprehend information more easily. It'll speed up your response time, but you'll be able to take information in and work it out and respond. So it may be in a conversation situation where you have to keep up with a conversation, and you're able to process that information a lot more easily. In the case of studies at school, you're able to take the information in, work it out, and respond. Or study and get the information in, understand it, comprehend it, and then when you have a question paper, you're able to apply that knowledge. So it's not just a case of regurgitating the knowledge, but you actually understand it and can apply it to whatever you have to apply it to. The improved processing ability, the cerebellum will improve its control of specific tasks. Remember, the specific tasks of the cerebellum are balance and postural muscles, automaticity, fine motor skill, so all the small muscles in the fingers, around the eyes and the mouth for speech, and processing ability to allow the information to be processed in and out. So that is specifically what is controlled by the cerebellum. So with having all these little information highways, as you can imagine by seeing the picture, all these neural pathways are developed, and there are these little information highways that the information can flow along. So as you develop the neural pathways, you have greater processing ability because you have more space that can actually transport that information more efficiently and more effectively. As the information flows more easily, your processing speed is going to improve, and then you will see improvements in everything else that you are trying to do that requires processing. So again, it'll help with learning, being able to get information into the brain and back out, and in conversation, etc. Specific stimulation via exercise. So as we've spoken about, we need to develop the neural pathways, and the way that we do this is via exercise. There is no other real way of doing it. So the only other way of trying to help the brain and control these things is by using medication. The problem with medication is that one, it's harmful long term, and secondly, it's only going to help while somebody is on the medication. So as soon as the person goes off the medication, the brain reverts back to what it was before. So you have a real roller coaster ride for the person that's on the medication. When they're on it, they're able to cope, they go off it, and they're back to square one, not able to understand anything and not able to process that information. So it is very unhelpful to somebody's self-esteem as well as to their actual ability to cope when they are going through this roller coaster of being able to cope, not being able to cope, being able to cope, not being able to cope. The other problem is that long term, that person has developed a mechanism of being able to cope by relying on drugs, by relying on medication. And the chances are that when they get older, that is their way of coping. They haven't learned to cope with the difficulties, both physically and emotionally, by controlling the brain themselves. They've relied on medication. So the chances are that later on in life, they're going to do the same thing. They're going to rely on medication, whether it be medication or recreational drugs. There's a huge correlation between children that were on drugs as a child that then turn to drugs later in life, because that's how they've learned to cope with it. So it's much better to intervene and help them to cope as a child so that they have learned how to cope with things as they grow older. To get back to the stimulation, so we need various types of exercise. Because we don't want to rely on drugs, we want to preferably do something that's completely natural and not harmful to the body. So we introduce exercises that are designed to stimulate all the different neural pathways that need to be developed. So you have various types of exercises. Because the cerebellum controls a number of different tasks, we need to make sure that we are stimulating all of those areas. If we just do eye tracking exercises, we're only going to be stimulating a certain portion of the cerebellum. But we want to actually make sure that we are stimulating the entire cerebellum. In this way, we need to do exercises that are stimulating the balance systems, that are stimulating the eye tracking, the proprioceptive system, etc. So we need to make sure that we are doing exercises that have a good array of exercises to make sure that we're stimulating all these different areas. While doing research on these types of exercises, they were doing an EEG on the brain to make sure that the exercises were in fact stimulating the correct area of the brain. And knowing that they are stimulating that area of the brain, we know that we're on the right track, that we're doing the right thing. Looking more specifically at the exercises, as well as doing all those different areas, they also organized in a very specific way so that they involve the different types of movement, stimulating the different areas, and making sure that all of this is done together at the same time, that it's not leaving any area out. So those exercises that stimulate the eyes, doing eye tracking, they're not only strengthening the eye muscles, but the movement of the eye muscles is controlled by the cerebellum. So that in turn develops the neural pathways that are being controlled by the cerebellum. So we're developing the cerebellum overall. When we do exercises that stimulate the balance system, again, because the cerebellum controls balance, we're going to ensure that those particular neural pathways are stimulated and developed. Likewise, exercises that involve turning on the spot or changing of the joint angles, it's all stimulating different areas of the brain, making sure that we are stimulating the entire cerebellum. To look more specifically at the exercises, we all know that exercise has a great impact on the body. Most people have done some form of exercise, played sport, been to gym, done bodybuilding, done weightlifting, whatever it might be. And we know that those exercises build the muscles or build the neural pathways in a specific way. So if you play tennis for many years, it's second nature for you to play tennis because those neural pathways have been developed. And even if you had a break and you go back to it, you could kind of pick up where you left off. You might be a bit rusty, but you would pick up where you left off because you have kind of grooved those strokes, and in turn, the part of the brain that controls those movements is well developed. So you would be able to go back and pick it up even after a fairly long period of time. The same with these exercises that we're doing. They are designed to stimulate the cerebellum. So they are very specific to target that area of the brain to make sure that we are developing that area of the brain. So the cerebellum has all these different neural pathways that fall under its control, and we need to make sure that we are developing all those to ensure that we are getting the brain to its maximum potential. So, as I said previously, it's not just the eye muscles, doing the eye tracking. We've got the balance system, and we have the postural muscles that are all included in that, and we have the proprioceptors. Now, the proprioceptors are tiny little receptors that are in the muscles and the joints, and they determine the angles of the joints for accuracy of your movement, to give you feedback for overall control of the physical movements. For example, if you went to pick up a jar, you would need to ensure that you are putting your hand around the jar, that your hand closes around the jar and you pick it up so that you don't drop it or fumble or slip and allow it to fall. So all those messages are going back and forth to the brain. The visual system and the eyes are going to help you to make sure that your hand is at the right level, but all the receptors in the little muscles and joints are helping you to ensure that your hand is around the jar and that you're closing your hand and you're picking it up. All very, very important for various movements, and that's why very often children with difficulties are clumsy. They may knock things over or drop a glass or spill things because of that part of the cerebellum that's not well developed. It's not helping them to control those movements. So to go into more detail about the balance in the vestibular system, the balance is just one part of what the cerebellum controls, and that in itself can be divided into various systems of balance. So there are 3 different major ways that the body controls the balance. Firstly, the visual system helps us balance. You know that if you close your eyes, it makes it more difficult to balance. We also have the proprioceptive system. So that is the little receptors that are in the muscles and joints. And if you go onto one leg and you cut out part of that proprioceptive feedback, it makes it more difficult to balance. The other very important part of the balance system is the vestibular system. The vestibular system, as you can see in the picture, is 3 semicircular canals that sit at right angles to each other. It's a tiny, tiny little organ in the inner ear, and those semicircular canals are filled with fluid. So when you start to move, the fluid in the ear starts to move. So if you tilt your head to the side, it helps to give you feedback to tell you where you have moved your head to or where you are in space, in other words, in the space around you. So it helps with spatial awareness. But how that applies is very important, because when you move, for example, if you spin on the spot, you are going to get that fluid in the ears, in the semicircular canals in the ears. That fluid is going to move. And if we put that into an application, we understand how that affects our movement in general. So the vestibular system, being these little semicircular canals, as you spin on the spot, you start to get dizzy. And that dizziness is because the fluid in the ears is starting to move. If the vestibular system is not giving you very accurate feedback, that fluid will continue to move, and we are sensing that it continues to move, and that is what creates the dizziness. So when we stop moving, the fluid's going to keep moving for a little bit while it takes time to settle down. And because we're not getting accurate feedback from the vestibular system, we experience that as dizziness. That is also why you would feel car sick or seasick, any sort of motion sickness, and attached nausea is also because of the vestibular system not giving you accurate feedback. The great news about this is that once you start to develop the cerebellum, the vestibular system will start to give more accurate feedback, and that motion sickness will start to settle. And if you think back to a generation or two ago, children used to play games where they were on merry-go-rounds, they were bouncing on trampolines, climbing trees, etc. All of those things were actually stimulating the vestibular system in the ears to help to provide more accurate feedback and to help to develop that part of the balance organ or the vestibular system. So working that all together, we've looked at the eye tracking in the previous training, we've looked at the balance in more detail now, and we've spoken of the proprioceptive system. So those are all ideal areas that we know we need to stimulate to be able to get the cerebellum developed. And along with that proprioceptive system, which is the joint angles, the receptors in the joints and the muscles that determine those joint angles, we can make sure that we're stimulating the cerebellum as a whole to get a result that we're looking for. Another huge part of developing the cerebellum is about mental tasks. So we want to get full development to take place for maximum success. With the additions of the mental tasks, we can make sure that we're doing that. So what mental tasks do is that they allow for the cerebrum to be occupied and taken out of the picture when doing exercises, so that the cerebellum has to do the exercise on its own. So we apply mental tasks once somebody has got into the exercises and they're starting to manage to do them easily and with greater accuracy. We introduce mental tasks which will take the cerebrum out of the picture and force the cerebellum to develop further and to get maximal stimulation. So that then allows for greater working memory space to be able to manipulate the information in the cerebrum, for that part of the brain to be able to process information more easily and perform its tasks more proficiently, more efficiently. And you can do more tasks at the same time because you are starting to separate the processing ability and the control of movements between the cerebellum and the cerebrum. And this applies very obviously when you play sport, for example. So if you're playing a sport like hockey or rugby or soccer, there's a huge field of play that you need to be cognizant of, where people are in the field, where people are in relation to you, where is the ball, so that when you get the ball, you're able to assess the field of play and pass that ball to wherever the best position is. Because if you hold on to that ball, obviously it's going to be taken away from you. So it involves a whole lot of processing. There are millions of incoming stimuli all at the same time. And the more efficient the brain is, the more you're able to decipher the most important stimuli and the most important information and make a decision on what your next best move is. So it's really important, and you see huge improvements in sporting ability because you're able to do a number of things at the same time. For example, you're running, you may be tracking a ball or dribbling a ball with a hockey stick, and you're able to assess the field of play and then make your next move. So it really does make a huge difference to sport. It can be very difficult before intervention to do things like playing team sports because you have all these incoming stimuli. So what you find very often is that somebody with difficulties often chooses individual sports because it's a lot easier. You don't have all these different incoming stimuli and people on a playing field that you have to just decipher a whole lot of information. It's you and a bicycle, or perhaps just running on the road. So it's just you and the road, you running, and it's a lot easier to focus on that. So typical sports would be paddling, cycling, swimming, and running, where it's just, you don't have to rely on anybody else or any other stimuli. You can just focus on yourself and what you have to do at that point in time. So once you're able to develop the cerebellum and you have this great processing ability, there's a definite tendency to interact with more people and play more team sports where it's easier to multitask and a lot more fun And obviously you're able to participate in team sports, which is great for camaraderie and for in social interaction and having fun with a group of other children or other adults. For more information on the mental tasks, we're going to do that in the next free training video. That will be coming along in the next few days, so keep an eye out on your email. You're welcome to drop some comments on the Facebook group. You can also respond via email if you have any questions. And I'd just like to take the opportunity to say thank you so much for watching, and I hope that this information is going to help you to help your child more easily. Have a great day.